Hey everyone, we're going to do 7.2, which is on verifying trigonometric identities, which are pretty cool. It's like proving identities to be true. So, for example, we have one here. How can we verify that that following equation is an identity? I mean, I guess you can plug in some x's and see if it works, but that's not really proving it. I mean, it might give you an idea that it's true, but how can we prove it? And so there's some techniques you can use, and I've listed them here in bullet point form. But the typical method is that first bullet point. You just start with the more complicated side and then simplify it until you get to the other side, right? And you kind of keep in mind that side that you're trying to get to. Like, so I'm going to try to reduce that cosecant over cotangent, and hopefully I come up with secant. Okay. Now, if both sides are equally complex, so if I look at that next bullet point, then I could work with each side independently and simplify them to a common third side, third result, I guess. Okay. So those are your two main techniques there, more so that first one than the second one, but they'll both work. One thing that you cannot do is that third one. You can't do equation solving techniques like adding something to both sides or multiplying something on both sides or working and doing an equation operation to both sides. Okay. You should not do that because we don't know that the equation is true or not. Okay. Now, the technique for going through and showing your work, each step should be showed clearly, and you transform the expression at each step, and then you have to justify your transformation. Like, what allowed you to do that? Did you use an identity? Was it algebra? So just a brief explanation. Some general techniques beyond that. If you're stuck, maybe try to get everything in terms of sine and cosine and see what reduces algebraically. Know your fundamental identities from that first page in 7.1. And also don't forget about the equivalent or alternate forms of the fundamental identities. They pop up. So do a substitution with those sometimes. And then it's algebra, algebra, algebra. Most of this is going to come down to algebra. So if you wanted to practice with some algebra, here's some little things that pop up. They're kind of similar to what you saw in 7.1, right? Like this one, sine squared over sine. You're just thinking of that really like in algebra, like a squared over a. You're just canceling an a and you're just left with a. Or in other words, this would just be sine x, right? Or this is the FOIL, right? 1 times 1 is 1. The outside is plus cosine. The inside is minus cosine. And then cosine times cosine, the last is cosine squared, right? And then those would just equal to 0. So this is 1 plus cosine squared. Okay. So a little practice, these kinds of techniques are going to be popping up. If you have an all quantity squared, think of that as just writing it out twice. Right? And then that's going to be first is tangent squared. The outside is tangent and the inside is tangent. So I have two of those plus tangent. And then 1 times 1 is 1. First, outside, inside, last. This would be tangent squared plus tangent, and tangent would be 2 tangents plus 1. Okay. So again, this is all algebra, but using, your variable as a trig identity. So that's reducing and multiplying. How about factoring? Remember factoring from algebra? Right? This is just like, you can ignore the sign. It's x squared plus 2x plus 1. And you can factor that out, right? So this is the kind where you try to factor it into two binomials. So your first term would be the variable sine times sine is sine squared, right? The last would have to be a 1, right? Because 1 times 1 will give you that 1 back. And then just verify that you'd get that 2 in the middle. That's from the outsides and the insides combined, right? So the outside is sine x, the inside is sine x, sine plus sine is 2 sine. All right, so that's kind of a reverse FOIL. So yeah, if you don't really remember your factoring and multiplying and things like that from algebra, these problems are a little harder. So, review, give yourself some practice with reviewing some algebra and then tackle these problems. Takes a little longer, but you can do it. All right, let's get into verifying identity. Oh, no, don't. More algebra. What about adding rational expressions? We did that a little bit in 7.1 when we had a problem. We have to get that common denominator. The common denominator here, let's see, I have to multiply this one by cosine, top and bottom. And over here, I have to multiply by sine, top and bottom, right? So this would be then, the top is, my goal is to write this as one fraction. Oops, I should go back to my blue. One fraction. The common denominator is cosine sine. The numerator is cosine times 1 plus 1 times sine. That's just going to be cosine plus sine. Okay, so you're going to have to review that as well. That pops up now and then, adding fractions. Okay, let's get to some verifications here. So again, I'm going to take it step by step, and I'm going to justify each step, reducing one side, the complicated side, to the simpler side. So there's that one we had at the beginning. So I'm going to start with that left side. All right, so when I'm doing my proving here, I'm going to write cosecant x over cotangent x. Okay, and then that equals, so I'm not writing secant here. I want to just string along a bunch of steps where my last one should equal secant. So my first thing, my instinct here is to use some identities. So I can replace cosecant at the top with a 1 over sine. And cotangent is cosine over sine. Right? So I replace the top and the bottom. My justification is here I use a reciprocal identity. And at the bottom, I use a quotient identity. Okay, so that's my little justification. Now from here, I'm going to do some algebra, right? So I'm going to think of division as multiplying it by the reciprocal. Right, so I would just write that, multiply by the reciprocal. Okay, these tend to be a little longer if I write them out like this, but next, what can I do? I can cancel, right? Or remove the common factor. It's another way of saying that. The sine's gone, right? And I'm left with 1 over cosine. So I would call that remove common factor. When you do these in your homework, you'll probably have some multiple choice or something like that, or drop down menu to choose your justification. Okay. And then finally, with 1 over cosine, it's secant. So we've proved it, right? And again, we used a reciprocal identity. Okay, so there you go. That's our process, right? Step by step, reducing one side down to the other. A lot of it is substitution with identities and algebra. Okay, so there's one. All right, how about another one? Number 2 here. So I'm going to start with that more complicated side. Maybe I could just say LS for left side, so I don't have to rewrite that whole thing. Let's do that. Okay, that 1 minus cosine squared, I recognize that as an alternative Pythagorean identity. That's sine squared. So that's sine squared alpha over sine alpha. right? So I used a Pythagorean identity. Okay, now I can reduce this, right? So canceling a common factor or removing a common factor. If you want to show that, maybe a little, I could write sine as sine times sine, sine squared as sine times sine, and then I can remove common factor. And then I'm done. Okay, so that one did 3 steps. Okay, pretty fun. Cool thing is, you know what your answer should be. You know, you're going to start with that complicated side and then just keep reducing it until you get to the other side. So my left side on this one, can't really do much with tangent squared beta. The variable keeps changing. How about cotangent plus 1? That seems familiar. Fundamental Pythagorean identity. Cotangent plus 1 is cosecant squared beta. So Pythagorean identity. Now I probably am going to do some more identities. Tangent is sine over cosine. So that's sine squared over cosine squared. And cosecant is 1 over sine squared. So I did a quotient identity and a reciprocal. Very sloppy when I'm going fast. I'll clean it up in the completed notes. It'll look better. And then now I can remove a common factor. That's 1 over. So remove common factor. Or some variation of that sentence. I don't know what they say in my lab, something like that. And then finally, 1 over cosine is secant. So that's secant squared beta. That's a reciprocal identity. And I did it. I reduced that left side down to the right side, right? Okay. We're moving right along. Should try another one. They'll just get harder as you go. But we'll keep on going here. How about cosecant minus sine? So I would say, I mean, this one, okay, which one's more complicated? I mean, I would say the one with the subtraction is more complicated. There's more you can do with it. So let's start with that side. So I'm going to start with my left side again. And I'm just going to apply a reciprocal identity. What am I trying to spell there? Okay, recip identity. I'll spell it out later. Now I'm going to have to get a common denominator, right? That's like that kind. So I would multiply by sine over sine over here. Okay. And then this is going to be now the top is 1 minus sine squared all over sine. And then what I did there is I combined using a common denominator. Okay. And then now I'm feeling good because at top I recognize it. 1 minus sine squared is cosine squared. That's an alternative Pythagorean identity. Okay, now what I'm going to do is try to separate this out into 2 factors because look what I'm after right here is 2 factors. So this, I'm going to separate it into cosine times cosine and then just write the sine under one of them. Okay, so that's separate into 2 factors. Right, and then now I can see that second one is the cotangent. Right, so this is equal to cosine times cotangent, and that was a quotient identity. Okay, And we did it. We proved it. Verify, prove, that same thing. Okay. Let's try one more. Oof. Fourth powers. What can we do with that? Well, that's factorable. Believe it or not. Sine to the fourth minus cosine to the fourth. That's going to factor into sine squared, the first terms, right? Because sine squared times sine squared is sine to the fourth. Cosine of the fourth is cosine squared times cosine squared, right? And then I need one plus and one minus. Right? So that's how that breaks down. It's a difference of two squares from algebra. Okay, there's my justification. And then that first one, sine squared plus cosine squared, that's equal to 1. That's a Pythagorean identity. So Pythagorean identity. And then now I'm trying just to get to cosine, and I got sine in there. So let's get rid of that sine, right? So I don't need that 1 anymore up front. Sine squared is 1 minus cosine squared. So I'm replacing sine squared with 1 minus cosine squared. And I'm just not needing any of the parentheses, right? So all I did there was I just replaced sine squared with 1 minus cosine squared and dropped the 1 and dropped the parentheses. And that's another alternate form of Pythagorean identity. So it's another one. Okay, and then I have some like terms, right? Cosine squared and cosine squared is 2 cosine squared. So 1 minus 2 cosine squared, and I've got it. And that's combined like terms. Okay, and then there we go. All right. Hopefully you're kind of following. You'll see some similar ones in the homework. So give them a try on your own, and send questions my way if you have any, and just keep practicing with them. They're fun when you get them. They're frustrating when you don't. But just keep at it. You got this. Okay, I'll talk to you later.